Hello everyone. Today we will start chapter number 3, organomagnesium and organolithium compounds. The organometallic were originally considered as a compounds containing carbon metal bonds. Carbon metal bonds. The organometallics were originally considered as compounds containing the direct carbon metal bonds, while with the metal like sodium, magnesium, zinc, cadmium, tin, mercury, etc. But later, organoboron, silicon, arsenic, phosphorus were also included under this group, even though these elements were not metals. Means the carbon is attached to the metal or non-metals. Okay, the term organometallics is defined as the compounds in which carbon atom of an organic group, carbon atom of an organic group is directly attached to an atom of metals or non-metals. The carbon of an organic group is directly attached to atom of metal or non-metal like boron, silicon, arsenic, phosphorus, etc., which are the less electronegative elements than the carbon. These are the elements which are the less electronegative than carbon atom. Simply, the organometallic compounds is the carbon atom is attached to metal or non-metals, metals or non-metals. That is the carbon is bonded to the metal or non-metals. Okay, carbon is a more electronegative than the metals. Carbon is more electronegative than the metal. Means carbon carries a partial negative charge, metal carries a partial positive charge. In a simple organometallic compounds, only alkyl or aryl groups are attached to the metal atom. In simple organometallic compounds, only alkyl or aryl groups are attached to the metal atoms. Only alkyl or aryl groups which attach to the metal atoms. For example, tetraethyl lead, tetraethyl lead, sodium acetylide, sodium acetylide, phenyl lithium, diethyl zinc, diethyl zinc. Okay, means in organometallic compounds, only alkyl or aryl group is attached to the metals. Here the ethyl group is attached to the lead. Here the acetyl group is attached to the sodium. Sodium carries a positive charge. This carbon carries a negative charge. Here this phenyl group is attached to the lithium. Lithium carries a positive charge. Phenyl carries a negative charge. Phenyl lithium. Now here the diethyl zinc. Here the alkyl group is attached to the zinc. Okay. In a mix organometallic compounds, in a mix organometallic compounds, organic group and another group are attached to the metal atoms. In a mix organometallic compounds, organic group and another group are attached to the metal atoms. For example, we know that RMGX, okay, RMGX. In this example, the magnesium is a metal and X is a halogens. Okay, this is a mixed organometallic compounds. Okay, mixed organometallic compounds. Alkyl group is attached to the magnesium. This magnesium is attached to the halogen. This RMGX. This is called as a Grignard reagent. This is called as a Grignard reagent. Means alkyl magnesium halide, alkyl or aryl magnesium halide. Okay. Another example, the RCDX, R cadmium X means alkyl or aryl cadmium halides, alkyl or aryl cadmium halides. The primary requirement of organometallic compound is the presence of the primary requirement of compound. The primary requirement of an organometallic compound is the presence of direct carbon metal bond. Direct carbon metal bond. So first primary requirement means carbon is a bonded to the metal. Okay. Therefore, there are the some examples are not considered as a organometallic compounds as they do not contain direct carbon metal bond. They do not contain the direct contain the carbon metal bonds. Now, for example, sodium ethoxide, sodium ethoxide. This oxygen carries a negative charge. Okay, sodium carries a positive charge. In this example, the carbon is not directly attached to the sodium, directly not bonded to the sodium. Okay, oxygen is bonded to the sodium here, the sodium ethoxide. Then another example, sodium phenoxide. Here also the same, oxygen carries a negative charge, sodium carries a positive charge. Okay, these are not organometallic compounds. Okay, the another is a trimethyl borate. Trimethyl borate. Okay, sodium carboxylate. Sodium carboxylate. Sodium carbonate. Here also the oxygen carries a negative charge, sodium carries a positive charge. These are the examples are not considered as a organometallic compounds because in this example the metal does not attach the carbon atoms. Okay, organometallic compounds means the carbon is attached the metals or the non-metals. Okay, this is a primary requirement is that. Now the next point is the nature and the reactivity of carbon metal bond. The nature and reactivity of carbon metal bond in organometallics. Nature and the reactivity of the carbon metal bond in organometallics. When carbon atom is attached to the metals, when carbon atom is attached to the non-metals like the oxygen, nitrogen, halogen, etc. When carbon atom is attached to the non-metals, X is here the non-metals. Okay, like the oxygen, nitrogen, halogens. Okay. Now here the when the carbon is attached to the non-metals, for example, X is the oxygen, nitrogen, halogen. These are the elements which are the more electronegative than the carbon atoms. These are the elements which are the more electronegative than the carbon atoms. So this X carries a partial negative charge because this X is a more electronegative than carbon atom. Okay, so this X is a which abstract the electron density towards from the carbon atom. The electron of the bond, the electrons of the bond are attracted towards the non-metal, which is a more electronegative, which is a more electronegative than carbon atom. Then the bond is polarized. The bond is polarized. So the non-metals carries a negative charge, okay, and this carbon carries a partial positive charge, okay. The bond is polarized. The carbon carries a partial positive charge, and non-metal, this X carries a partial negative charge. When the carbon is bonded to the metal, in second case, the metal is bonded to the carbon, okay. So here the carbon is a more electronegative than the metal. The carbon is a more electronegative than metals. Okay, so carbon is carries a partial negative charge and metal carries a partial positive charge. When carbon is bonded to the metals, the carbon is a more electronegative. Okay, and metals are the more electropositive. Metals are more electropositive, and carbon is a more that is a negative, more electronegative than the metals. Okay, then the bond, this carbon which abstracts the electron density from the metals. Okay, the electrons in the bond are strongly attracted towards the carbon. Therefore, the creating the ionic character, which create the ionic character of the bond and making its polar with carbon having the partial negative charge, and the polarity is reverse. And the polarity is reverse means here in the first case when the non-metals is attached to the carbons, means non-metals, for example, oxygen, nitrogen, halogens is attached to the carbon atoms. These non-metals are the more electronegative than the carbon atoms. So these halogens, non-metals means more electronegative atoms carries a partial negative charge, and carbon carries a partial positive charge. But in second case, when the metal is attached to the carbons, metal is attached to the carbon, metals are the more electropositive elements. Okay, Then carbon is a more electronegative than the metals. Then carbon which abstract the electron density from metals. Okay. Then the creating the bond is polar and is creating the ionic character of the bond. The carbon carries a partial negative charge. Hence, the organometallic do not exhibit 100% covalent character. The organometallic do not exhibit the 100% covalent character. The electropositivity of the metal increases. The electropositivity of the metal increases. The ionic character of the carbon metal bond also increases. The electropositivity of the metal increases. The ionic character of the carbon metal bond also increases. That means the carbon of an organometallic compound has a Carbanian character. The carbon of an organometallic compound has a Carbanian character. What is a Carbanian? Carbon carries a negative charge. The carbon of an organometallic compound has a Carbanian character and it behaves as a nucleophile. It behaves as a nucleophile. This carbon this carries a negative charge. Okay, Carbanian character, and it behaves like the nucleophile. Nucleophile is a electron rich species. Is attacks on the electron deficient species. Okay, what is a here Carbanian like the nucleophile. Nucleophiles are the electron rich species that attacks on the electron deficient species. The polarity of the carbon metal bond is in the following order for the metal series. The polarity orders. Okay. Now these are the metals here. The given the polarity of potassium is more than the sodium. The polarity of potassium is more than the sodium. The sodium is more polar than the lithium. Lithium is a more polarity than that of the magnesium. Magnesium has a more polar than the zinc. Zinc is a more polar than mercury. Mercury is a polar than the copper. So these are the order is given the polarity of carbon metal bonds. In this order, the potassium has a more polarity characters. Okay. Therefore, for examples, the organolithium compounds are more polar and hence more reactive than the organomagnesium. This lithium is a more polar than the magnesium. This organolithium compounds are the more polar than that of the organomagnesium compounds. Organolithium compounds are more polar and hence are more reactive than the organomagnesium compounds. In this chapter, we will discuss the organomagnesiums and the organolithium compounds. Organomagnesiums and organolithium compounds. Organolithium, the polarity of lithium is more than that of the magnesium. Since organolithium compounds are the more polar and more reactive than that of the organomagnesium compounds. A variety of organometallic compounds have been used as an excellent reagent. A variety of organometallic compounds have been used as an excellent reagent to prepare the wide range of the organic compounds. Organometallic chemistry is one of the most fascinating field in the contemporary organic synthesis. Organometallic chemistry, one of the fascinating fields in the contemporary organic synthesis, and the newer compounds are being developed for better and efficient applications. And newer compounds are being developed for better and efficient applications. The organometallics are one of the best procedures for the carbon-carbon bond formation. Organometallic are one of the best procedure for carbon-carbon bond formation in organic transformation. So today we stop here. Thank you.